Okay, so last week and the week before we were solving systems and they were only of two variables. And we are going to take it up a notch and solve with three variables. And we're going to start by substitution just like we did with our two variable systems. And so we're going to take it step by step. So on your notes, make sure you also write down the steps, at least on this first problem. So on this first problem, make sure you write down the steps, what you do first, what you do next, and it's already laid out here for you. Just make sure you're following along. So we have this three variable system. The first thing we need to do, step one, is to solve for one variable because again, we're going to be solving by substitution. So best thing to do is look for an equation that has a variable that has a coefficient of 1. So looking at this one right here at the top, I can easily solve for x. So by doing that, I can add the 3y to the other side, subtract the 6z to the other side, and leave the 21 there. So all I did was I added 3y to both sides, and I subtracted 6z to both sides. So that's why I had plus 3y here and minus 6z, okay? So I just rearranged it so that the y came first. So x is equal or equivalent to this right here, okay? So now it says plug into another equation and then try to simplify it, okay? I'll take this second equation right here, and I will plug in this expression for x. So I have 2x, but I'm not going to put the x. I'm going to put 3y minus 6z plus 21 in its spot, okay? And then I need to finish writing the original equation. So I have a minus 5y, a plus 2z, and that should equal negative 6. So again, we're going to do this and we're going to simplify it as much as we can. First thing I need to do is go ahead and distribute. So I'm going to distribute this 2 to every term inside that parentheses. So I'm going to have 6y minus 12z plus 42. And then I still have the negative 5y here and the positive 2z, and it still equals negative 6. All right, so we're still going to have to simplify some more, especially on this left side. We have some like terms we need to combine. There's 6y and a negative 5y. So those combined would be just a 1y. 6 minus 5 is 1. Then I have negative 12z and a positive 2z. So negative 12 and a positive 2 combined to make negative 10. Z equals 42. Oops, plus 42. Plus 42 equals negative 6. Okay? And so in order to have everything where it should belong as far as combining like terms and making sure everything is together on one side, I'm going to go ahead and subtract this 42 so that it can come over here with the negative 6, and all our constants will be together. So I have y minus 10z equals, when I combine negative 6 and negative 42, I get negative 48, okay? So I've simplified it into a two-variable equation. Now, I need to take this second equation that I haven't used yet and bring it all the way down here, where I am going to plug that x in again. Okay, so I have 3x plus 2y minus 5z, 3x plus 2y minus 5z equals negative 6. Okay, and I need to plug in my equivalent expression of x. Okay, so forget this x right now. I'm going to plug in that same expression we got earlier, which is 3y minus 6z plus 21. 3y minus 6z plus 21. So I plugged it in for this x right here. I still have to put plus 2y minus 5z equals negative 6. Hold up. Wait a minute. All right, so we got, it should equal negative 30. And I back checked. So we need to take away that negative 6. That was our first one. It's actually going to equal negative 30. All right, so again, I'm going to distribute. Now I have 9y minus 18z plus 63 plus 2y minus 5z equals negative 30. Okay, so let's combine like terms again. 9y can combine with 2y, so that's 11y. Then I have negative 18z and negative 5z. That combines to negative 23z. And I still have this plus 63 here, which equals negative 30. But just like we did earlier, let's get the constants all together on the other side. So I'm going to subtract 63. And so my final two-variable equation would be 11y minus 23z equals negative 93. So next step you need to write down is we want to solve this two-variable system. We just made two-variable equations. So my first one, if you recall, was y minus 10z equals negative 48. And then my other one was 11y minus 23z equals negative 93. Okay, y'all know me, I like to do elimination, but you can stick with substitution if you'd like. So I'll go ahead and do that for this one since we do have this y here that can easily be isolated. So if I rewrite this equation, it will change to y equals 10z minus 48, because remember I have to add that 10z over to both sides. So plus 10z. Okay, so I'm going to use these two equations right here to find my value of z. Okay? We're getting there, we're getting there. So I have 11, and instead of y, I'm going to plug in that 10z minus 48. Still have the minus 23z equals negative 93. So if you notice, plug this in all the way over here for this y. Okay, so distributing again, 110z minus 528 minus 23z equals negative 93. Cool, cool, cool. All right. I'm going to combine 110 and negative 23, which will give me 87z minus the 528 that's still there equals negative 93. Add the 528 over, and I'll have 87z equals 435, which when I divide by 87, I get z equals 5. Woo! All right, cool. So we have z. We need x and y still. All right, so we're going to plug in to one of the two-variable equations, whichever one you want. I think it would be beneficial to go ahead and plug into that y equals that we did earlier, y equals 10z minus 48. Remember up there? Okay, and so since I know z now, I have 10 times 5 minus 48. So y is 50 minus 48, which is 2. We are so close. All right, and we gotta solve for x. And to solve for x, I can use that x equals equation that I used earlier. X equals 3y minus 6z plus 21, and I have to plug in y and z. So my y is 2, so 3 times 2, minus 6 times my z being 5, plus 21. Do some calculations. We get 6 minus 30 plus 21, which means that x equals negative 3. So how do you write that? Your solution will be written as negative 3, comma, your y 2, comma, your z 5. Okay, so we are going to do a second one just to make sure that we're all on the right track. Again, you have to solve for one variable. And looking at these three equations, I'm noticing that my second equation does not have x in it. So, whichever variable, if in this case you have an equation where one of them doesn't have all three variables, whatever the missing variable is, I would solve for that one variable. So for example, this one's missing x. This second one right here, missing x. So I'm going to solve this bottom one for x, okay? It'll make your job a lot simpler. So whenever you see that, go ahead and solve for the variable that's missing, okay? So I'm going to get x equals, I'm solving for x, solving for one variable. My negative 21 is already there, but I have minus 3y minus 2z because I'm subtracting these two guys over to the other side so that my x is isolated, okay? Now, it says to plug into another equation and then simplify. So I'm just going to go ahead and throw it in my top equation because that's the only one I can. So I have 2, but instead of x, I have to put this expression, negative 21 minus 3y minus 2z. You still may want to write down these steps, okay, because this is the exact steps that you're going to have to take in order to completely find your x, y, and z. All right. And so again, I'm using this top equation. I can't use the second one because I don't have an x in it, okay? So I'm going to finish by doing minus 2y plus z equals 3, okay? Now let's distribute that guy. 2 times negative 21 is negative 42. 2 times negative 3y is negative 6y, and I don't know why I wrote 3. 2 times negative 2z is negative 4z. Minus 2y plus z equals 3. Okay, so let's simplify this thing. I have negative 42. I have, that's it. Okay, so let's add that over. And then negative 6y, negative 2y, that's negative 8y. Negative 4z and positive z, that's negative 3z left over. And remember, we're going to move this negative 42 by adding it. So plus 42 plus 42. So that's going to equal 45 on this side. This is why I told you to solve for the missing variable, okay? Because I don't have to plug into another equation because I have a 2-variable system. Because I can bring this second equation over here, and I can bring the one I just did. So I get to skip this step because my middle equation did not have an x, okay? So right now I have negative 8y minus 3z equals 45. And I also have my second equation, 5y minus z equals negative 31. All right. So let's keep going. I'm going to use elimination this time. And I'm noticing that I have a negative 1z here. I can easily make that into a positive 3 so that my z's will cancel. So I'm going to multiply by negative 3. So then I'm still going to have negative 8y minus 3z equals 45 on my top equation. Here I'm going to have negative 15y. I'm going to have positive 3z. And I'm going to have a positive 93. And with elimination, you add down. So I'm going to have negative 23y. These are 0. I have 0 z's left over. and I have 138 here. So let's divide by negative 23 to get y. And that gives me a negative 6. All right, I'm a third of the way there. Still got to find x and z. Okay. So let's plug this y in. We can plug it into either of the equations. I'll just bring this one down. So 5 times negative 6 minus 1z equals negative 31. This is negative 30. Minus 1z equals negative 31. Add the 30 over, and I'll have negative 1z equals negative 1. So when I divide out by negative 1, I get z equals positive 1. All right, we're 2/3 of the way there. We just need to solve for our last variable. And remember, we solved for x earlier in the game. So we got to bring that back down. X equals negative 21 minus 3y, but my y is negative 6, minus 2z, but my z is 1. So I'm just evaluating this. Negative 21 plus 18 minus 2. So x is going to be negative 5. Yay, I got all of them. So my final solution should look like so. Negative 5, comma, negative 6, comma, 1. The end. Okay, so then you're going to try to find the lengths of all sides of this triangle, and we have a perimeter of 65. Okay, so basically they gave you one equation here. There's your equation 1. Here's your equation 2. And your third equation is going to have to be L plus M plus N equals 65. Okay? And remember I told you earlier, so you have all three of these equations here. I noticed that one of them is missing a variable. So this one is missing an N. So that's what we need to solve for. How convenient. This one's already solved for N. So in that case, we're going to go ahead and plug it into this equation here. So instead of putting L plus M plus N, we're going to put L plus M plus L plus M minus 15. And all of that should equal 65. So all of this came from here, that second equation. So start combining like terms to simplify. I have 2L's plus 2M's minus 15 equals 65. And we're going to add that 15 over so we can get all the constants together. So 2L plus 2M equals 80. So we already have a two variable system because remember we have this L equals 1/3 M up here. Okay, and so I can plug that in for here, that L here. So 2 times 1/3 M plus 2M equals 80. All right. Well, 2 times 1/3 is 2/3, so I have 2/3 M plus 2M equals 80. I'm going to eventually get my first variable solved here. And I need a common denominator, so I'm going to make this 2/3, and 2 is actually 2 over 1. But since I want it to have a common denominator, I'm going to have to multiply top and bottom by 3. So I have 2/3 M plus 6/3 M, which equals 80. Look at me. I am so optimistic. Look how my writing keeps going up like that. All right, so I have 8/3 M equals 80. And the best way to get rid of a fraction in front of your variable is to multiply by its reciprocal. Because if you recall, If you're going to divide, you're going to have to multiply the reciprocal anyway. So you might as well just do it to begin with. So times 3/8 times 3/8. This will just give you 24/24, which is 1m. And over here, I make this a fraction, and that will give me 240/8, which is 30. So we got m equals 30. Okay, so we have our first variable m, which can then help me find L, because L, remember, is 1/3 m. So L is 1/3 times 30, which, if you put that as a fraction, 30/1, 1 times 30 is 30, 3 times 1 is 3, which means that L is 10. Okay, and now that I have L and M, I can find N, because remember, N had its own equation. N equals L plus M minus 15. So 10 plus 30 minus 15, and 40 minus 15 is 25. So we found the length of all three sides, L, M, and N. L is 10, M is 30, N is 25, and if you add all those up, you do get 65.